Hi everybody, welcome to Graduate Statistics. Welcome back to Graduate Statistics Week 13, University of Cincinnati. This is the lab portion. We will work on a problem that requires multiple regression to help us solve. We want to figure out a way or identify variables to predict milk production in a particular month. So I want to know, beginning the month, I want to predict more or less how much milk will produce. What are the kind of variables that will help me forecast, basically, what will be my milk production that month. So we'll work on a data set that will allow us to create a model for that. And you can imagine you guys are going to be in organizations and, for planning purposes, sometimes it's useful to know what it is that will be, what will be the outcome of whatever it is that your product is that month. How can I forecast what my profit will be that month, or how, what's going to be the health outcomes that I'm trying to change that month based on particular predictor variables. So it's kind of useful to figure out how to create models from data. Because multiple regression is a bit of a hard type of analysis to grasp, and the step-by-step process is a bit more involved, what I planned was to take you through this class where you don't have to really program up anything, and your task will be to take this report, which would be like taking the report from a data analyst who's working with you. Imagine, you're working with milk producer, and you want to figure out and help that milk producer understand how to predict the milk production for a particular month. You're working with a data analyst. The data analyst provided you with the R&D where all the analysis were run. And what you will have to do is to create a document, a report document, to present to your company, right? So your document will have a little explanation of the problem and what you're trying to do, and then the results of the analysis that provides the best model for the prediction, and you would have to be explaining what it is that model is showing, and using, like a figure that will help you illustrate that. There will be no right or wrong. You will try to use your creativity the best you can to create that report. Somebody gave you an R&D with the analysis. How do you create a report out of that R&D will be your task for this week, to communicate the data analysis to somebody that needs to understand what the model is showing. Okay, so you will have your words describing it. I provide you here with interpretation of the findings, and you will write those interpretations in your own words using whatever figure you think will be most helpful to try and communicate the findings to somebody that does not understand much of statistics. So you can't use statistical jargon. You have to try and try your best to communicate that idea. So it's your attempt that will matter. And now we'll teach you how to copy figures that you generate in your R&D to a Word document, so that you can use those in order to create your document. All right. So let's read what the problem is. General description of the problem and data set. So here's what I want you to imagine. That you're working with a farmer that hired you because they want you to help them understand how to best plan the business, okay? To best plan the business, one of the things that is important to know is what is kind of predict ahead of time and forecast what will be the milk production in a particular month before actually the end of the month, so that you're not surprised. Oh my gosh, this is how much we produced this month. Is there a way to predict what it is that the current month production will be based on some information about previous month milk production and some characteristics of the herd that you have. All right. Now, you contacted a data analyst who is going to help you with that task. So your goal will be to work with that data analyst, and the data analyst will, use a data set and provide you with a model to predict current milk production. And your task will be to translate the findings that the data analyst got you to the farmer that you work for. Okay, that's what I'm saying will be your task this time. To take things out of this RMD and create a report that will be understandable and clear and with illustrations for your boss to understand what it is that he has to base to kind of what are the variables that he needs to look for in order to forecast how much milk they will produce on a particular month so that they can plan the business better. Yes? All right. So what you and the data analyst did was to figure out where you can get data in order to help that particular farmer. So you got data from the Dairy Herd Improvement Cooperative in upstate New York, which is sort of an institute that collects and analyzes data on milk production. This is real data set, okay? One question of interest here is how to develop a suitable model to predict current milk production from a set of measured variables. The response variable then is current milk production in pounds, and the predictor variables are given below, and we're going to discuss them in a bit. The samples are taken once a month during milking. The period that a cow gives milk is called lactation. The number of lactations is the number of times a cow has calved or given milk. The recommended management practice is to have the cow produce milk for about 305 days and then allow a 60-day rest period before beginning the next lactation. So data set consisting of 199 observations was compiled from the DHI, this cooperative, milk production records. So that's what the data analysts work with. I got this data set from this book on regression analysis, and we'll work with it together today. So imagine I'm the data analyst working with you. I'm going to go through what I found with you, but your job is to describe what we found to your boss who has no knowledge of statistics, right? So you're the middleman trying to bridge the gap between a data analyst and somebody that you respond to and that you want to work with and convince them on practices that need to be done. Okay? All right. The response variable in the data set is called current milk, which is the current milk production in pounds. Predictors. You have the previous month milk production in pounds, and that variable in the data set will be called previous, and that's a numerical variable. Fat, the percent of fat in milk, that's numerical. So if you take milk out, measure the fat, is that a good predictor of current milk production? Protein, percent of protein in milk. Days, number of days since present lactation. Lactation, number of lactations in total that cow has ever, been subjected to, I guess. I-79 is an indicator variable which receives 0 if days since present lactation is less than 79 and 1 if days are greater than 79. Now listen, number 4 and 6 is pretty much measuring the same thing. Basically days since present lactation. This one measures it in a continuous kind of metric, and this one measures it with a categorical variable that either gets 0 if there's less than 79 days or 1 if there's more than 79 days. All right, so the data set is called milk production, and it's a text file that's right here in your files. And because it's a text file and it's not a CSV, we have to use a different function that's read.delim. And then we'll create a data structure, data set just like you're used to, a data frame. Right here, as you're used to, so we have 199 observations and then 7 variables, which are these variables that we just discussed. Okay, one is the current milk, which is the response variable, plus 6 predictors. So let's check the data structure and make sure each variable is identified with the correct data type. So str milk data, and if I look here, current milk is kind of as an integer, which is not really, so we want it to be treated as numerical. Previous milk production, same thing, it's a continuous numerical variable. Fat is a continuous numerical variable. Protein, same. Days, it's a numerical variable as well. Lactation, same thing. And I-79 should be not an integer, but a factor, right? It's just 2 categories, 0 and 1. I could have words there to describe this, less than 79, more than 79. But I'm just using the data set as I extracted it from the website. So what I'm doing here is adjusting all of the data set, all of the variables, because I don't know how this will show up in RStudio Cloud. So just to be sure, I'm saying, okay, let's get the variable current milk inside of milk data and make it numeric because it's integer. So I use as numeric and I put milk data current milk. I do the same thing with previous. It's integer here, I'm transforming to numeric. And then I'm doing this for fat. And you can say, oh, but it's already numeric. It is my computer. It does. There's no guarantee that the same will happen in RStudio Cloud. So I'm just having it here just in case. All right. Now, let's do some data exploration. Remember that plot that you saw in class that you had, you know, the scatter plots on one side and the R values, the R coefficients on the other side. We'll create a plot that looks like that. It's not exactly like that one, but it looks a lot like it. And it's actually a little bit more complete. The function that I used to create that plot somehow is not working anymore. I don't know if that package got outdated, whether I need to install something else, but I couldn't quite figure out in time, and it's getting late. It's 10:12 already. So I think I'll just use a different function to get the plot here for us. And that function that we'll use is called ggpairs, because what it does, it gets pairs of variables and it creates a scatter plot and it gives us the correlation coefficient of these 2 variables. So it basically does the same thing, but the plot, as you will see, looks a little different. So when you use ggpairs, you have to pay attention to a couple of things in the syntax. The first thing here is the data set that you want to plot, so you can investigate the correlation between all pairs of variables in the data set. You can actually specify the columns that you would like the correlations to, you know, just to indicate which variables you want to be included in that correlation plot. And I'm just making R use all of the columns, but you can actually pick and choose. You can say, oh, I want the response variable plus 3 other variables only. You could do that if you wanted. But because I know nothing about milk production, I will just look at all of it, right? I'm being like this naive data analyst that knows very little. You're giving me these variables that you say might matter, so I'm going to just check them all out. And then this thing is just for me to mess with the size of the font that is plotting out the correlation coefficients. Here I'm giving the theme and also just asking for the font size of the labels of the plot. Okay, so you might have to play with size of both the fonts of the variable names, the labels, and of the correlation coefficients, the font that is used to print that. But the way you do it, you run the code. If it looks too small or too big, you just mess with these numbers. Okay, and the columns, you just pick the ones, if this data set only had 4 variables, you would have to delete those. If you didn't want to look at correlations between all of the variables in the data set, but just the first 4 columns, or column 1, 2, and 5, you can adjust this according to what you need. Okay, so now I will run this. And what we'll see takes a little bit because it's creating all of these scatter plots and computing all of these correlations. So it takes a little more time than usual. But it will pop out, hopefully. Maybe? Okay. It did. Here it is. I will stop the video now because we're already 15 minutes in. I will upload this video and we'll come back to discuss, what this plot is and how to interpret it. Okay? See you soon. Bye-bye.